Now let's look at the example where we had the two or more changes in sign. And I had kind of done one over here and my error 7 is still up there. So this one has the following cash flows, and you can see the negative 800 to plus 5,000 to negative 5,000. So when you go to calculate the NPV, let me just go to the cash flow and set it clear work, 800 negative, and enter for the cash flow 1 or cash flow 0, and then cash flow 1 is 5,000. Enter. Cash flow 2 is 5,000 negative, and enter. So NPV, it says the weighted average cost of capital is 10. So hit 10 and enter. Go down and hit compute. Negative net present value, negative $386.78. So I would reject this project. IRR, I go to IRR and hit compute, and it gives me a number. It doesn't give me an error message like they say here. So this example was a little bit different than the one I did before. So it's telling me one of the two internal rates of return that this has. So what I'm saying is every time there's a change in sign, negative to positive, positive to negative, this series has two changes in sign, so we'll have two internal rates of return. One of them is 25%, and the other one is some astronomically big number. And if we look over here at the NPV profile, you can see the first IRR we got was 25%. But then it has another IRR of 400%. Because when you get into that, more than one change in sign, it just goes crazy, and it has two or more IRRs based on the number of changes in sign. So there are two IRRs that would make the net present value equal to 0, and you can't make a decision at all with the project. So now again, we talked about the MIRR does solve this problem. It will give you a rate and it won't give you an error. Well, this one didn't give you an error. It's kind of like a silent error that you don't know about. And you can use the modified internal rate of return, and that would give you something. So this is just the summary slide of why there were two IRRs. It's kind of confusing, so I don't really try to go through and explain it. I think it's really better if you just remember the number of changes in sign equals the number of IRRs that you'll have. And so you need to always be careful looking at the timeline and making sure that there's just one change in sign. So what if we use the modified internal rate of return for this project since it was so difficult? Well, if you remember, step 1 was to get the present value of the negative cash flows or the outflows, and the weighted average cost of capital was 10%. So we took the negative 5,000, and let's see, the cash flow was negative 800 at the beginning. And so that gives us a present value of those two together summed is 4,932. And then if I get the future value of the $5,000 just for one time period, if you look back at the timeline, if it increases by 10%, then I have $5,500. And I could go to my calculator and put 4932.23 negative as the present value. The terminal value of the inflows as my future value, so 5,500 future value. Let's see, this one was a 2-year project, and 0 is payment. We have no payment, and I hit compute I, and I get 5.6%. So we can compare 5.6% to 10%, and we can say, yeah, that's a bad project. We should reject it because 5.6% is less than 10. And then we also already knew that the net present value was negative 386. If I went to NPV, 10 is already entered, and then I need to compute. Maybe I already did that. What's $386? Like we knew. So we'd reject based on both the NPV and MIRR, but again, the net present value method is always the best. And so we have reached the end of chapter 11.